Sorry, I didn't see you there. Just practicing the new instrument I'm taking up. This is called the fouet. It's the Japanese bamboo flute. I hope you're similarly exploring some different interests during this time. Most importantly, I hope you are keeping up with your work. I know Mr. Boothman is putting in quite a bit of effort to make these as entertaining, as engaging, and most importantly, as educational for you as possible. So please respect that. Put in an equal amount of effort. Okay. Let's go ahead and bring Mr. Boothman on, and we'll get started with today's lessons. Let's get started. Happy Friday. It is College Friday, so go ahead and ask me any college questions you might have during our Google Meet today. You have an exit ticket due by midnight tonight. Now, today is our Unit 7 review, so this exit ticket today is your opportunity to submit any last questions you might have about the unit as a whole, and I'll do my best to get those answered before our exam on Monday. I'll answer those in this video lesson before you take your exam on Monday. Okay. Now, your exam on Monday will be digital. Think of it as just all of the exit tickets we've taken so far, but combined. Okay, so hopefully you're prepared for that. Follow along with this practice. Follow along with the other practice and review that we have available to us from the rest of this unit. And let's get started. Okay, so today has a Metroid theme. I am going to actually post this review with all of the answers. And in those answers, I did include a little more detail than I even normally would otherwise. So because of that, I'm not going to work through all of these problems. Most of them are fairly straightforward. 7.1, pretty easy. Okay, adding vectors, finding the magnitude, finding a unit vector. Okay, remember this is just taking our vector and dividing that vector by its magnitude, so that will force its magnitude to equal 1. Finding the horizontal and vertical components. Horizontal component is always A, vertical component is always B, and we have our formulas for those. Those come from our trig functions, our triangle, if we drew out our triangle. Finding the angle between two vectors, that's that wonderful formula that is given to us on our reference sheet. Work, that's another formula that's given to us. I would like to work through this last problem, however. Okay, so work through this problem yourself along with all the others, and then go ahead and come back to this video so we can compare your work with what I'm about to write. A plane is traveling due north at a speed of 500 miles per hour relative to the air. So what does relative to the air mean? That just means that if the air were still, okay, the plane's speed is 500 miles per hour. A strong wind is blowing in a direction of north 80 degrees east at a speed of 60 miles per hour. Okay, so let's start by drawing this picture. We have our plane traveling due north. I'm going to call this plane vector P. And so the magnitude of vector P is its speed, in this case, 500 miles per hour. A strong wind is blowing in a direction of north 80 degrees to the east. So north, and then we're turning 80 degrees to the east. And this is our wind vector, call that vector W. And its magnitude, its speed, is 60 miles per hour. Find A, the resultant velocity of the plane as a vector in component form. So we want to write vector V as some sort of vector AB. So the resultant velocity is going to be the plane's motion plus however much this wind is pushing it. So the plane isn't just going due north. Because of the wind, it's being pushed to the northeast slightly, so the plane is actually going to end up going there. So this is vector V. All right. So vector V equals vectors P plus W. So we need to find vectors P and W. Let's start with vector P. We need to find our A and our B. A, of course, is the magnitude times the cosine of the angle of vector P. Magnitude of vector P is 500. The angle that vector P makes in standard position, okay, so if this is our vector, then that's a 90-degree angle. So theta is 90 degrees. The cosine of 90 degrees is 0, so 0 times 500 is 0. The vertical component of this vector is the magnitude times the sine of its direction. So 500 times the sine of 90 degrees. The sine of 90 degrees is 1 times 500 is 500. So vector P is the vector 0, 500. And now we do the exact same process to find vector W. Now, the horizontal component of vector W is its magnitude times the cosine of its direction. Its magnitude is 60. Its direction, again, that's in standard position. So if this angle is 80 degrees north, 80 degrees east, then the direction of this vector in standard position is 10 degrees, since that's a right angle. And so we plug this into a calculator. 60 times the cosine of 10 degrees is approximately 59.09. And its vertical component, similarly, 60 times the sine of 10 degrees is approximately 10.42. So these are our pieces. These are not angles. These are the components of the vectors. So think of them as the speed of the vector in the horizontal and vertical directions. So our vector V is P plus W. So that's the vector 0, 500 plus the vector 59.09, 10.42. 0 plus 59.09 is 59.09. 500 plus 10.42 is 510.42. I ran out of room there on the board. So this is our vector V. So I'm going to write that up here so I can erase this because we'll need it for parts B and C. All right, so let's move on to parts B and C. This is the vector, the true velocity of the plane in component form. Okay. Part B is asking us to find the true speed of the plane. So the true speed of the plane is going to be the magnitude of this true velocity, which is the square root of 59.09 squared plus 510.42 squared, the square root of a squared plus b squared. Using a calculator, we get its true speed as 513.83, and this is in miles per hour. Okay, so pretty straightforward. The true direction of the plane, so we just found the true magnitude of this vector. Now we want its direction, so we're looking for theta, this theta right here. We're using our trusty tangent function. Tangent of that angle is equal to b over a, so that is the vertical component of this vector, 510.42, all over its horizontal component. Since we're solving for theta, we take the inverse tangent. And we should get approximately 83.40, and I was in degree mode, so this is in degrees. Now, if we're writing our direction, if we're expressing this angle like in the problem, north 80 degrees east. Okay, so let's think about this. 83.40 degrees would be this angle right here. Now, if we want to express this as our direction, we're starting north, and then how much are we turning and in which direction? So if this part is 83.40, then the rest of this angle here is 6.60, subtract from 90 degrees, and that was in the east direction. So this right here is the true direction of the plane. Okay, so all of this will be posted, that entire answer key, so please work through these problems, check your work. If you can do these problems well, you shouldn't have any issues on your unit exam on Monday. Okay, study, practice, join our Google Meet session, send me any questions you might have. Your exit ticket today is due by midnight, and then please, please, please study. All right, have a good weekend. Thank you, Mr. Buchman. The rest of you, I hope you have a fantastic weekend. Join us for Google Meet later today and ask your College Friday questions, and I'll see you all next week.